Okay, the first three problems are inequalities. And so I just want to make sure that we talk about the different types. Number one is called a one variable inequality. You see how it just has one letter in it? Okay. So step one is to pretend that it's equals. The first step for all three of the first problems is to pretend that it's equals. And I want you to notice number one and number two, they have something in common. They have, yes.
They have a constant in front of the 4 times 6n plus 1.
Genius, absolute genius. Okay, and the reason that we did that is because we want to make sure that we go over not combining unlike terms. So this -4 minus 4 cannot be combined into -8. Do not do that. Absolutely no. Negatory. Nope. Nope, a lope, a ding dong. Now on this one, I'm not too concerned because most people's instinct is to distribute. So that's not a big deal. So last week, there was a medical emergency in Mr. Coach T's class. And then yesterday, someone passed out in Mrs. Rice's class. So if we could just not keep the streak going, that would be amazing. I really appreciate all of us doing the in and out breathing, and the staying upright and conscious thing. That'd be great. Okay, anyway, +8. Okay, now on these CUDA type problems, being this is the software that we use to make these worksheets, if your answer is one of the values on the number line or in the range on your number line, that should be telling you that you're on the right track. If it's not on there or really off of there, you're not on the right track. So you should check that. Okay, next question is open or closed? Open. Okay, make your open circles obnoxious because your teacher, her eyesight's failing any second now. It's true. Okay, now I want to test 0. So I'm going to make a little spot here. So this would be -6, -5, -4, -3, -2, -1. 0 would be over here somewhere. I don't really care where. I just want to make sure that I make my 0 on the correct side of my open circle. What's the only thing I cannot test? -6. You can test anything else, just not -6. But Mrs. Talbot, that makes me just want to test -6. Well, it's not going to do you any good. Oh no. I was telling my funny story and then I forgot a parenthesis. Now everything's. Thank goodness I have a erasable pen. Okay. So -4 minus 4. 6 times 0 is 0 plus 1 is 1. I don't know that I even need to keep going. This, whatever this is definitely less than 136. Okay. So this side is true where I plugged in 0. The solution set is always where it's true. You want where the answers are, what works, not what doesn't work. So your arrow goes toward the solution set, the true side. And then final answer, n is greater then -6. Okay, so this is an example of a one variable inequality where there's only one solution and your arrow just goes left or right. Do you guys have any questions about this one? I want to point another thing out too. Do you see how this is less than right here? Does everybody see that that's less than? Okay, do you notice my final answer is not less than? Okay, what I'm saying is you actually have to test. You can't just take the thing from the problem and put it in the answer. I wish it was that easy. Then half of my job would be over. But unfortunately, you actually do have to like follow the steps and test it. Oh man, Mrs. Talbot, I thought I just picked up on an easy cheat. No. Yeah. Okay, number 2, same thing, but absolute value style. So pretend you have equals. Okay, and I put this one in here on purpose. I'm trying to trick you. I'm trying to trick you into making this 9 minus 9 0. You cannot do that. I want you to think of it like this. 9 minus 9, and then I just took the absolute value and replaced it with x. What would I do first in this problem over here? Subtract 9. So we want to do the same thing here. And because you're not allowed to distribute into absolute value, what do we do instead? Yep. Okay. How do I undo absolute value? Plus or minus, and plus or minus on the 1. And some of you guys are going to be like, but Mrs. Talbot, all that stuff's negative and it's going to turn to a positive. You don't worry about that. This side stays intact. This side gets the plus or minus. I'm going to say that again. This side stays intact. This side gets the plus or minus. I skipped a couple of showing works there to save space. Okay, I should be encouraged by the fact that both of my dots fit on my number line. So I know I'm on the right track. What's the best thing to plug in this problem? -8. Yeah. Now you can plug in anything you like except -9 and -7. Those answers are taken. But -8 is the best one. Okay, let's go slow here because this is confusing. 9 minus 9. So -8 plus 8 is 0. So anything times 0 is 0. False. That means the solution set is not at -8 or anywhere between those two dots. So the solution set has to be outside. Arrows out in my final answer, just like arrows are out in the picture. Okay, now I have a question. Just because this is notes, what would happen if I got true? Let's pretend that I did this math here and I got true. What would it look like? It would look like Baymax. It would be like this. So if I got true, it would look like that. My final answer would be -9 is less than or equal to n is less than or equal to -7. This is how my answer would look if I had gotten true. That's how my answer would look if I had gotten false. I got false. The problem is false. I'm just trying to hypothesize since we didn't cover all options. I just wanted to say if we had gotten true in the middle, it would look like Baymax, and my final answer would look like that. My Baymax is a little wonky. There we go. He looks better now. Okay, anything that you want to add about number 1 or 2 before we move on? Number 1 or 2, anything? Good? Okay. All right, scooch down to number 3. What shape is this? Parabola. Okay, and so I'm going to make a table for my parabola. And what is the vertex? 4, -3. So that's going to go in the middle. Okay, so let's do Mrs. Talbot's mental math methods. What is 5 minus 4? 1. 1 squared. 1 times -2 plus, no, -3, -5. Okay, 6 minus 4. 2. 2 squared. 4 times -2, -8 minus 3, -11. Now, should we be worried? Look at our graph paper. We're fine, right? Okay, so 4, -3, 3, -5, 2, 6. Okay, next question, dashed or solid? Okay, next question. Oh my goodness. Next question. Is 0, 0 okay to use to test? And let me ask you a different way. Is 0, 0 on my parabola? No. So it is okay to test. I'm going to put a little circle just to indicate a visual of where it is. It is outside the parabola. 0 is greater than -2 times 0 minus 4 squared minus 3. Okay. So this is -4 Negative 4 squared is 16. 16 times negative 2 is negative 32 minus 3 is negative 35. Is 0 greater than negative 35? True. Okay, so that means that anything I would have plugged in outside would have been true. And I shade where the true things are because that's the answer. Okay, before I move on from number 3, how many variables does this have? 2. So you see the difference between a 2 variable inequality and a 1 variable inequality. 2 variables, just a graph. It's like 2D versus 1D. Okay, number 4. Solve each equation. Remember to check for extraneous solutions. Okay, so undoing a square root is squaring both sides. But because this is notes, I want you to write this. Again, undoing a square root is squaring both sides. But because it's notes, I want you to write this because this will tell you to do the box. Just writing this squared, people make a lot of mistakes. They don't do the box and then they get to the end and it's not diamond and boxable. They don't know why. It's an answer that doesn't work. So if you remember, this is it's like a parabola on its side, but it's only half. And this is a line. It's sometimes they cross in 2 spots, and sometimes they cross in 1 spot, and sometimes they don't cross at all, which means that you have to check your answers in the end. So this is kind of the moment of truth right here. So if you did it correctly, this should diamond a box, which I believe it does. Okay, so get there. This is not done, but get there first. Okay, then what we're gonna do is plug them back in and see if they actually work. So this is the part where we remember to check for extraneous solutions. So over here, gonna do 7 times -3 plus 22 equals -3 plus 4. And here I'm gonna do square root of 7 times 2 plus 22 equals 2 plus 4. Okay, that one works. That one works. They both work in this case. Now, if you remember from the work that we did in our notebook, if one of them didn't work, I lightly crossed out the one that did not work and I boxed the other one. Sometimes they both don't work and it's no solution. There's no rule. I wish I could tell you a rule again, just like the testing the thing, you have to actually do this. Now you can sort of cheat. You guys know how to cheat? You can actually verify that both work if you do solve by graphing real quick with your graphing calculator and just check your answers in the end. I really like these because you can walk away like, okay, I showed all my work, I have all my stuff, but I can verify before I leave. Violet, do you see how like if the line was lower, they might only cross once? And then do you see if the line was higher, they might not cross at all? So that's why it's possible. Sometimes both work, sometimes one works, sometimes neither work. It just depends. It's been a minute. It was like the very first thing we did. Okay, anything else from number 4? Excellent questions. Okay, flip. Okay, square root function. Let's see. Square root function looks like this. Y equals a square root x minus h plus k. And it's telling me that the end point is hk. And the other point that it passes through is an xy coordinate. Any questions with what I did so far? So I figured out which type it was, wrote the general equation, and figured out what was hk and what was xy and plugged in. Okay, now I have to do order of operations, and I always suggest undoing this constant first because people will try to combine unlike terms. So rescue the 3 out of there. 22 minus 6 is 16. Okay, so -10 equals 4a. Square root of 16 is 4. And reduce. You can also say -2.5 if you'd rather. Okay. Last step, just plug it back in. And there's your equation. Any questions about number 5? I think that's my favorite so far. Okay, number 6. Solve the system of equations both algebraically and graphically. Let's do graphically first, and then I'll move the paper down. Okay, so for the parabola, the vertex is 1, -5. Okay, 2 minus 1 is 1. 1 squared is 1 times 2 is 2 minus 5 is -3. 3 minus 1 is 2 squared is 4, 8, 5, 3. Okay, now this is a line. I don't know how you guys like to graph your lines. You can make a table if you want to. I'm just going to graph it with slope and y-intercept. So this is y-intercept is 1. I'm going to put a dot at 1, and then the slope is -2. So I'm going to go down 2 over 1, and then up 2 back 1. Okay, so my points of intersection are -1, 3, and 2, -3. Everybody agree with those points? Okay, so that's the graphically piece. And the good part is you're going to be able to match your algebra with this. Okay, so for the algebra part, I'm going to come down here and do equal values method. The first thing I'm going to do is undo the x minus 1 squared. Now, you don't have to do this all the time. Do you guys know when to do it and when not to do it? You don't know? Cody knows. You don't know. Okay, it has to do with this. Because there's an x here, it has to be combined with the stuff from this box. So you have to do the box. If this was just a 1, if it was just a constant, you could solve by square roots. Okay, so again, if this is just a constant, you can solve by square roots. If it's got an x in it, then you have to multiply it out and combine everything. Okay, now distribute. Okay, now I'm going to get it equal to 0 and box and diamond. Kinda. What do you notice about this? Well, it's all even. It might be a perfect square, but okay, now we get to kind of cheat on this problem because really all we need to do is just check to make sure that our x's match the x's of our coordinates up here. And we already got the y's from the graph, so we don't have to plug it back in to get the y's. Do you see what I mean? You just have to be like, oh, x is 2 and -1. Oh, I got 2 and -1 from my graph. So this just needs to jive with this. It's a lot, but it's kind of satisfying in the end because it matches. All right, one more problem, then we're done with this. Complete the square. All right. Step 1, minus the constant. Okay, step 2. What is it? Kinda. What's divide by 2 but not divide by 2? Do you see it? And you can divide by 2 if you want to. I just think this is a lot less work, but Okay, here's the moment of truth. I'm going to add 16 to this side, but what am I really adding? 32. Okay, A equals 2, H equals 4, K equals 10. Positive 4 on the H, by the way, be very careful. Any questions about number 7? We're getting the vertex form down. Okay, so the next thing I want to do is, well, I need to give people a minute to write, but after that, we're going to look at the test topics and the point values. And then we're going to start working on the team test, which you can flip to. It's right on the next page from your packet. Okay, let's all read this together. The test is on Tuesday. You can use a notebook and a calculator. Handwritten blog. Okay. First two, multiple choice ones. Solving an absolute value inequality. You know what that is? Pretend it's equals, solve, plus or minus, 2 dots, test the thing in between, out or in, they max or yeah, number line, yep, okay. Number 2, I don't know if it's number 2, but the second thing, graphing a system of inequalities. That's the one where you graph 2 things and you find the double shaded region. We're going to practice that, by the way. We have a scavenger hunt thing of that after the team. So that's like Friday and Monday. Solving a square root equation and checking for extraneous solutions. And definitely not forgetting about the box. You know what that is? Square both sides, make sure you do the box, plug it back in, see if they work. Okay. Identifying the locator point in a transform graph, any from the paragraph summary organizer, and writing the equation, including solving for A. Okay, on your review notes, that was the one, that was number 5. I look at your review notes, it was number 5, where you have like, you like, okay, this is the square root 1. I identify HK, plug in HKXY, solve for A, and then write the equation. It's gonna say, or it's gonna have a picture. So you're gonna wanna make, yeah, on your note card, I would put like the type, yeah, and then just a little sketch of what it looks like, and then the locator point, and then the equation. You don't need domain range, I mean, you're into that stuff. Solve a system of equations both graphically and algebraically, so that's like the parabola and the line, finding where they cross, and then doing the equal values method and finding where we did that on quiz too, if you remember. It was like the first problem on your last quiz. By the way, I can pass it back to you too. And then completing the square rewrite to vertex form, which is what we just did a second ago. Constant, GCF, add the stuff, be careful that you distribute. You guys know what all those things are? Yeah. Okay, so I am going to put up the team test sheet. It's awkward because one page is copied in color as I like them to be, and the other page is not. I know. What I'd like you to do is try to get to the first three today. That'd be great. So I'm gonna put that up back here over by Barrett. And you guys should be working on that. And I think that's it. Oh, do you know what the homework is?